will use the process proposed by Alan Turing to do a simple calculation. In this case, the calculation will be the easiest one possible, 1 plus 1. But the process itself could be used to do anything a normal computer could. Alan Turing never built an actual machine, but here is what it might look like if someone did. To work the machine, you would write inputs onto the paper strip, and then the Turing machine would start at one end, reading the first square and using an instruction set to tell it what to do next. These instructions might include moving the tape, erasing whatever is in the square, or writing something new in the square. We've drawn a series of squares here to represent the tape, and here we have the instructions the machine would use if we told it to do addition. To add two numbers, we would write each number with an X on either side and a space in between them, like this. The machine starts by reading the right-hand number on the tape and starting at instruction 1. So the process would look like this. If the cell has a 1 in it, move left 1 and go again. If the cell has an X, erase the X and get 2. If the cell is blank, move left 1 and go again. Then repeat this instruction as the cell is still blank. If the cell has an X, erase the X and get 3. If the cell is blank, move left 1 and go again. If the cell has a 1 in it, erase the 1 and get 5. If the cell is blank, move right 1 and go again. Then repeat this instruction as the cell is still blank. If the cell has a 1 in it, move left 1 and get 1. If the cell is blank, write a 1 in it and get 6. If the cell has a 1 in it, move left 1 and get 3. If the cell is blank, move left 1 and go again. Then repeat this until the cell is no longer blank. If the cell has an X in it, erase the X and get 4. If the cell is blank, move right 1 and go again. Continue this until the cell isn't blank anymore. If the cell has a 1 in it, move left 1 and get 6. If the cell is blank, write an X and go again. If the cell has an X, the program is complete. Our answer is X11X, which is 2, which is exactly what we were hoping for. While this example is almost trivially simple, it would work for adding any two numbers and with a different instruction set do any possible computation.